So any process which yield well-defined result or statistical data is called experiment. A sample space containing only a finite number of outcome is finite samples space. Finite means countable. If you are not able to expect the result from the experiment, so no doubt which is a impossible event or null event. Hello everyone, a warm welcome to one and all. I am Natesh, lecturer in Commerce, Vidyashram First Grade College, Mysore, the Temple of Excellence. We are in the Unit 3, Section 1, third semester BCom, Probability Distribution. And today my agenda, you will get to know the introductions of probability, what is probability, and the theory of probability, why it is very important, and the probability basic terminology, what and all which is related to probability. Okay, so moving forward one by one, so we will get to know introductions to the probability. So the probability, you must understand, there is a, when coin is tossed, either you are getting head or tail. So how you are able to, the chances of occurring a result. So here during the 17th century, the concept of probability originated as a theory of game, because which is related to puzzles, which is related to game. So when you are playing a game, of course you are expecting a probability result, a probable result you are expecting, the chances of occurrence here. So and the game or chances, you can say the theory of game and chances. The theory of probability, why? Because the different person, according to their opinion, what they said. Okay, so the theory of probability, which is developed by the Galileo, James Bernoulli, P.S. Laplace, A.N. Kamloger, and others. Okay, here during the 17th century, the probability concept, which is related to who is developed the theory of probability. Okay, the theory of probability is Galileo, James Bernoulli, P.S. Laplace, A.N. Kolmogorov, and others. They developed this concept. Okay, so why it is very important for the, when it is related to the real world, where it is necessary for doing a probability. The word chances, we are just replacing the word called chances. In case of when we are saying a chances, better we can use for probability the chances of occurrence result here. Okay, the chances of probably is used very often. For example, probably he may get rank in the examination. Everybody is expecting a result, either a pass or fail, either he can get a distinction or first class, second class. So the probability is nothing but which is expected result here. So such a chance statement became a precise if we express this term of proportions or percentage, what percentage we are able to expect the result. Either I'm getting a rank. So if anybody asking today, if it is if there is any rain, the probably you can expect, or may not be, you cannot. Okay, so here there is a 90% chance that he may get rank in the examination, because when the term in case of we are using it, the chances of getting a result, instead of using a chances word, I can use it probably or likely. So it is a percentage base and proportions base. We are expecting a result here. Moving forward, so the theory of probability, the probability is a numerical measure of chances occurrence of an event. So anything which is related to numbers only, we are saying here, the probability is a numerical basis, a numerical measuring. So which is nothing but when we are taking an event A, event B, everything is which is related to numbers, so we can say it is a numerical measures. Okay, so the probability theory provide a basis of statistical inference. Inference means what? Which is nothing but a decisions making. Using a statistical, how we will go for decisions making. So which is nothing but statistical inference means what? Decisions making. So on the basis of this theory, only insurance company, there are not only insurance company, many company, they are using a probability theory. So they will get, they are expecting the result for using a probability. So here the insurance company, when they are fixing a premium for any product, insurance product, so based on the probability they are deciding here. So company fix the premium because there are different plan is provided for the unique person, okay, based on their education insurance, or you can say life insurance or general insurance. When the company want to decide to fix what is the premium amount, so using a probability only, so they try to fix an insurance premium. Therefore, the concept of probability is very much needed to develop various techniques in the statistics. Here, the statistical area, or you can say business, or even economy. So, everywhere the statistical are using, the probability theory are using. So, we will get to final result here. We need the following terms. Understand the concept of probability. If you want to master in the probability, you want to understand the basic concept, whatever it is, which is related to the probability. So moving forward, so the first one, experiment. So the probability, which is completely depending on the experiment, what you are going to conduct, what types of experiment you are doing here. So the experiment means what? So any process which yield well-defined result or statistical data is called experiment. So either the experiment which is related to dice, or experiment related to playing cards, experiment related to picking the ball. Okay, so all whatever which is related to, you need to do for. So that's what when we are trying to go for probability related problem, we are trying to apply the simple EPP. E stand for experiment, P stand for possibility. What is the total possible result you are able to expect, and the probability, of course, you are expecting. Yeah, so that's what EPP is very important. So if you are trying to expect a result from the probability, of course you need to select the experiment, right result we are expecting. So next one, outcomes. Of course, any probability you are doing an experiment because of outcome. Either it is a favorable outcomes or unfavorable outcome. Here the outcome means what exactly in the basic terminology based on the probability concept. A result of an experiment. What we are trying to conduct experiment, of course we are expecting a result here. So result from the experiment means which is related to the outcomes is called for, okay, a result of an experiment is called an outcome, because we are conducting an experiment. Why we are doing experiment? Because we need to get the result. Next, deterministic experiment. Deterministic experiment means when we are trying to conduct, of course you are able to expect the result. So when you are able to determine the result, so here the deterministic experiment, which is an experiment which has a unique same outcome, unique or same outcome. Unique outcome. If head came means the tile will not appear. If tile is came means head is not appearing. When you are rolling a dice, when you are able to get hard numbers or even numbers, okay, so unique result, unique outcomes we are able to expect from the experiment. When repeated under identical condition is a deterministic experiment. The one coin, two coin, three coin, two dice, one dice. Okay, each and every time when you are rolling or conducting an experiment, you are expecting a deterministic experiment, which is a deterministic condition result we are able to expect. So there is one example just for understanding here. So noting the water temperature, because when at the time when you are boiling a water, so each and every process, each and every stage, we are able to identify what is the temperature level. If it is boiled 180 degree or 200, okay, the temperature level, if it is increased, the boiling temperature, of course you need to make a note here. So in boiling process at a different time point, different. So 5 minutes or 10 minutes intervals when we are try to take a note on this. Next, when random experiment means what? So when you are trying to conduct, suppose there is one classroom, you want to pick any two students. So randomly you are inviting, so randomly you are picking. So which is nothing but from the out of total sample space, you are picking whatever which is a representative, a random experiment, an experiment which does not have a unique outcome, does not have a unique outcome. For example, the total in the classroom there are 100 students. I just want to pick 2 students for girl, 2 students for boy. So randomly I am picking, so which is a unique result we are able to expect here. when repeated under identical condition in the random experiment, because I clearly specified what kind of experiment I am doing, how I can pick the representative. So the number here, there is one example, number of head obtained when two coins are tossed. When two coins are tossed, so you are able to expect 2 into 2, 4 result we are able to expect. First result head, next tile, one head, one tile, one head, 4 result we are expecting here. So that is a number of heads in this examples when we are trying to go for an experiment like random experiment. Moving forward, what is sample space? Because when sample space is completely depending on what kind of experiment you are doing. For example, the experiment EPP, if you try to say, so experiment which is related to dice, if you say there are 6 phases you are able to identify here. The sample space, which is nothing but you have to write in the capital letter yes. So in the dice we are able to identify 1, 2, 3, 4, 5, 6, because the die is having a 6 phase, the total sample space will be 6. Now here we are able to identify the possibility result is a 6. The probability is assigned for 1 by 6, because one time if you row one unique result you are expecting, either your what kind of numbers you are expecting, so we cannot predict. After conducting experiment only we are able to note. Okay, so here the set of all possible outcomes samples point a random experiment. Be using a random experiment, the sample space I have specified here one example for die related. It is denoted by yes, capital S, capital letter yes. So when it is you are writing, so which is representing a sample space here. For example, when a die is rolled, sample space will be already explained here. The total phase, how many phases we are able to identify in the die, we are able to identify here 6 phases. Okay, next, the finite sample space means when the sample space, when you are able to count, so that is a finite sample space you can say. When you are rolling a dice, we are able to expect a even number or odd number. So the finite sample means you are able to count. A sample space containing only a finite number of outcome is finite samples space. Finite means countable. For example, when a coin is tossed, one coin is tossed, either you are able to expect head or tail. This is actually, the possibility will be, total result will be 2. Okay, this is countable. One is head, one more time is tail. Infinite sample space means when the number is not able to count. Okay, in case of intervals, okay, the degree, temperature, okay, in the class interval when it is specified, we are not able to count here. So a sample space with uncountable number of outcomes is an infinite sample space. For example, the body temperature may be between 98 degree to 104 degree, because exactly we can't say. So based on the intervals, so when we are studying which is related to infinite sample space, here the point in the interval cannot be counted. That's what we can say, it is an infinite sample space. Moving forward, now we need to understand each experiment is having a different, we are able to identify event, what kind of event. If you take the dice, so in the dice only we are able to identify number of events, even number 1 event and odd number is 1 event. If you take example, which number is multiplied by 2, which number is multiplied by 3, okay, so that is also we are able to note down here. An event is a set of outcome of a random experiment. If you take a coin, so there are 2 phases, one is head and tail. When the event is set for head, we are writing the probability of head. Okay, when we are writing for, when we are expecting a result for tail, the probability of tail. So now head is one kind of event and tail is one kind of event. Okay, there are different types of experiment according to what you are expecting the result. Okay, so according to the result we are setting a event. Okay, so an event is a set of outcome of a random experiment. It is a subset of sample space, because in the dice, if you take example, there are 6 results you are able to expect. So 1, 2, 3, 4, 5, 6. Okay. In this total samples, again we are dividing into even numbers and odd numbers. Even number is one kind of event and odd number is one kind of event. So we are writing like this. Capital letter event are denoted by the letters capital letter A and B and C. Like this it is extending here. So in case of which is related to the experiment, what kind of experiment you are doing, and their outcomes are denoted by small letter A, B, C. That is the outcomes what you are expecting from the total events, total sample space. Now null events are impossible event. If you are not able to expect the result from the experiment, so no doubt which is a impossible event or null events. Okay, an event which does not contain any outcome is a null or impossible event, which is symbolically we are representing a null symbol. So which is nothing. When you are writing like this, if you written, okay, there is, you are not able to expect the result from the experiment whatever you are conducting. Either when you are raising a coin, okay, the coin, for example, when you are expecting a face, head or tail, any one result. The coin is standing like this, you are not able to expect the result, so which is treated as a null events. Now simple or eliminatory event, an event which has only one outcome is a simple or eliminatory event. Only one outcomes you are expecting from this. Okay, that is. Now compound events, just which is just opposite to simple. Okay, an event which has a more than one outcome is compound event. When you are expecting from the experiment more than one time, so that is compound event. Okay, moving forward. Sure event means what? Of course you are expecting the result, that's what you can say it is a sure event. Okay, an event which contain all the outcomes of a random experiment is a possible sure event, or you can say certain event. It is nothing but sample space. For example, one coin if you take, either you are expecting head or tail, this is your sure event. Either you are expecting head or tail, so this is your sure event. So next, favorable outcomes means what? So the outcomes which entail the occurrence of event are said to be a favorable outcome of that event. Favorable outcome means what? When you are conducting an experiment, either you are expecting head or tail or even number, odd number. If you take example for playing cards, okay, you are able to identify there are two colors, red and black. There are four design, heart, spade, club, flower. Okay, so there are different types of numbers will be assigned. We are able to identify card. So now next one, exhaustive event. Exhaustive events, which is nothing but the total samples, the total outcomes we are expecting from the experiment. So exhaustive events are the total number of possible outcome of any random experiment. Okay, the total experiment, what types of result you are able to expect, the total result we can say exhaustive events. For example, in throwing a dice, the event A is set for odd numbers and event B is set for even number. Together are called for exhaustive event. But the total sample, which is nothing but total sample, then also we are dividing into A and B. A is denoted for odd numbers, B is denoted for even numbers. Moving forward. Now, equally likely event, because if you take example for coin again, so there are two ways you are able to expect. One is head or tail. When head came means tail will not appear. When tail came means head is not appearing. That is nothing but equally likely event. Okay, or you can say probable event. Two or more events are said to be equally likely if they have equal chances of occurrence. Okay, there is while tossing a fair coin, the event head or tail are equally likely when both you can't expect head and tail same time. You can't expect tail and head the same time. One, if you are expecting a head, okay, there will be a chances of occurrence of head, okay, or tail. So equally likely means head came, means tail will not come, okay. So next one, union of event. Now I told you there are different types of experiment having a different types of events we are able to identify. When we are able to identify different events together, we can say it is a union, okay. For example, again, if you take the dice, okay, even A set for hard numbers 1, 3, 5. Okay, even B is set for even numbers 2, 4, 6. When which is related to union means how we are writing. Now we are writing A union B. Together we are writing 1, 2, 4, 3, 4, 5, 6 together. When it is when the union is always having the total sample space. Okay, yeah, union of two or more events is the event of occurrence of at least one of those events, okay. So which will not repeat one more time, okay. For example, even A or even B, if you take, suppose the even A, whatever the number it is there, which is same, the same number is repeated for B, but we are not writing one more time because already it is there in the event A. So that's what we are just ignoring. 2 times we are not writing, we are writing only 1 time. So I hope you clear. So once again, the union means the total A and B, whatever the event having a result which cannot repeat one more time. So only 1 time we are writing. So that is the set of events, okay. Thus, union of 2 events A and B is the event of occurrence of at least one of them, and it is denoted by union always having a A union B, okay, this symbol union combine, okay, and or you can say A plus B plus sign you are able to identify, or A or B if they specified, okay, here unions symbol plus symbol or, okay. In this case we are saying it is a union event. Why it is very important? Because based on the problem when we are trying to do, so we must know the basic terminology before solving the problem. So there is one example. While tossing a 2 coins simultaneously, 2 coins means what? 2 times the total result will be always 4, okay. So here the 2 coins are tossing simultaneously, the same time you are throwing. If A is a event of occurrence of 2 head, A is a event of occurrence 2 head, and B is a event of occurrence of 1 head, the samples I have writing here, the total 2 coin samples we are able to get 4 times. So either you are getting head, or you can get a tail, head, or you can get a head, tail, or you can get a tail, okay. Now in this case, the union A set for what it is denoting, so you need to get 2 head, okay. So the event B, what it is saying, at least you have to get 1 head, at least 1 head you have to get. So in this case, we are able to identify the 2 head means only 1 time. The total result will be 1 by 4. Okay. So in this case, at least 1 head means here 3 times we are able to get 1, 2, 3. So we are in this total result what we are writing. So 3 by 4. So from the out of the data, the out of experiment what we are getting result. So we are able to identify. So here you must familiar the symbol U plus R which is related to union of event. A union is a event of occurrence at least 1 head. So when we are writing A is a 2 header, A is a 2 header because it is clearly specified 2 header, and B is at least 1 head means 1, 2, 3. But tiled we are not taking. So A union B means what we are writing at least two times which is came head, two times came, at least one time again we need to count for this one also. Total we are getting 3 result. Okay, moving forward. So here intersection of event, when we are writing, when we are trying to do for experiment, setting a event number 2 or more event, which number is common, so that number we can say it is the intersections value or intersection outcomes we can say. So here intersection means the intersection of 2 or more event is the event of simultaneous occurrence of those events. Now, for example, event A also we are able to identify number 2, event B also we are able to identify number 2, so which is a common number is repeated, so we can say intersection. So, the intersection value is a 2. Thus, intersection of two event A and B, the event of occurrence of both of them, okay, it is denoted by intersection symbol, or you can say multiply symbol, or you can using the and. Why it is very important? When we are trying to solve the problem, so based on the symbols equation we are able to decide what exactly we need to specify. Okay, here there is one example. While tossing a 2 coin simultaneously, before that we need to write EPP. E stand for experiment, experiment which is related to 2 coin. Okay, the possibility outcomes, there are 4 possibility outcomes we are able to identify. Each probability will be 1/4, because when you are writing a samples, so you can write like this: head, head, or tile, tile, and head, tile, and you are writing tile, head. The possibility will be, we are able to identify, there is a 4 result we are able to expect here. Okay, so if A is a event occurrence of 2 head, okay, now we are setting with the help of samples, we are writing the probability what we are getting head. Okay, so how many heads we are expecting? 2 head we are expecting. 2 head, how many times we are able to expect? We are able to expect only 1 time. Okay, so next one. B is a event of occurrence 1 head. Then A intersection B is the event of, how we are writing? A is both. Okay, in the total samples only, A represented 2 head, B represented here 1 head. So head. Now in this case, sample A will not repeat in the sample B. Sample B which is not repeated in the sample A. So we are not able to expect the result. So we can decide it is a null event, because the result is missing, which is common here. Event A also there is no common result, and event B also there is no common result. So we can say A intersection B is a null event, because in the symbolically we are writing, so null event is always, you have to write like this. Okay, next one. So mutually exclusive event, or you can say disjoint event. Okay, when mutually exclusive event means what? When head came means tile will not come, and when tile came means head will not come. When odd numbers you are expecting, even number is not you are not able to predict. So here the 2 or more events are said to be mutually exclusive. If occurrence of one event prevent the occurrence of other event is a single trial. Using one trial, one experiment, we are able to expect either head or tile, even number or odd number. So at the same time, we are not able to expect head and tile together. So for example, while tossing a coin, the event head and tile. For example, head is you have assigned A and tile is we assign B. So event A and event B are mutually exclusive, because when coin is tossed once, the result cannot be head as well as tile. Only we are able to expect one result. Okay. Next, complement of an event. For any event A, the complement of A is a event of non-occurrence. For example, we are able to expect the result, favorable result, unfavorable result we are assigning nothing but A dash, or you can say A bar, okay, or you can say complementary AC, because whatever you are expecting a result which is occurrence already occurred, so which is not occurred, so nothing but which is a complementary, okay. It is the event constituted by all the sample point which are not in A, which are not in A. For example, if the two coins, if you take head and tail, okay, the probability of getting head, so you are writing 1 by 2 because the total result is 1 by 2. If you want to get non-occurrence result, means 1 minus 1 by 2, which is nothing but A dash, okay, which is non-occurrence result. The complement of A is denoted by AC, which is not occurred, okay, or you can say A bar, you can say A bar, okay, or you can say A dash, okay. So this is a symbolically representing a non-occurrence result. For example, while throwing a die, A is 3 and 6. It is a complement is A dash, which is a favorable result, which is the unfavorable result, which is not occurred, which this one is already occurred, okay. So here A is an event of getting multiply of 3, because the question, according to question, multiply of 3 means what? You are able to get 3 ones are 3 twos are, this is your favorable result. Unfavorable result means which number is not multiplied with the 3. So that's what I have written here, 1, 2, 4, 5, okay. So multiply of 3. A dash is an event of getting non-multiply of 3. This number is not multiplied by 3. Keep on watch for next section. Thank you.